So optimization has some real world analysis. That's why we do these things. Okay? If you ever run a business or have anything in the world that you want to make some money on, you're going to make the most money if you optimize your situation. Okay? I want to make this box, so I use the least amount of material and get the most amount of space. Things like that. Those are the types of problems we're doing today and understanding a little bit what's going on. Okay? When we are optimizing, technically you've done this back in pre-calc, but it's been a minute. All right? You follow some steps here. We're going to identify what's being given. We're going to figure out what we're trying to maximize. We're going to write it with just one variable. And then we're doing what we did yesterday, which is maximizing. Take the derivative, set it equal to 0 and solve. Throw it on our number line and see which one's the biggest. All right, that's what we're trying to do. So let's look at example 1. Example 1 says find two numbers whose sum is 48 and whose product is a maximum. So we look at this problem. I can tell it's an optimization problem because we're trying to find the maximum or minimum of something. When you look at this, what are we trying to find the maximum or minimum of? Product is a maximum. We are trying to maximize product. All right? And so our product equation is what we're trying to maximize. Of two numbers. They didn't tell us what the numbers were. The numbers are a mystery. What two letters would you like to use to represent those numbers? Too long. We're going with X and Y because you guys are bums and you're going to give me annoying letters. X and Y. So we need a product equation. So the product is going to be equal to, I'm using the letters X and Y. What are you going to do with X and Y to find the product? Yeah. Multiply. Product is equal to X times Y. Cool. The problem with that is this is what we're trying to maximize, product. But I have two letters going on here. I have X and Y, and I've got this equation product. I can't maximize that yet because there's just too many variables going on. And so they better have told me something else because I want to rewrite this equation to just have one letter instead of two. All right? And they did. They told me two numbers whose sum is 48. Two numbers whose sum is 48. So how could I write that in equation? X plus Y equals 48. This is the equation that matters. Okay? This product equation is the one that matters because that's what I'm trying to maximize. But this is going to help me to figure this out. My product equation right now has X and Y. I'm going to use that other information to make this first equation just have one letter. Okay? Think back to your Algebra 2 days. We are going to do substitution here. So we are going to solve this for a letter. Which letter would you like to solve for? X or Y? X it is. We're going to get X by itself. So if I want to get X by itself, what am I going to do? Subtract Y. X is equal to 48 minus Y. I just took that X, took that Y and moved it over. Cool. That's an equation. This is what X is. And so what I'm going to do is whatever I made X equal to, I'm going to take this and I'm going to sub it in for the letter X because this is what X is, it says. X equals that. And so I'm going to rewrite this equation. Product equals 48 minus Y times Y. I put 48 minus Y in for X, and then it's going to be times Y. Everybody good with this equation so far? I'm going to clean it up a little bit. I'm just going to distribute that 48 just so it's less ugly. Or distribute the Y, sorry. Product equals 48Y minus Y squared. Now I have an equation. This product equation is what I want to maximize. It's written with just one letter. So cool. If I want to maximize, what am I going to do with an equation to maximize that equation? I'm going to first take the derivative. Once I take the derivative, then I'm going to set it equal to 0 and solve. So that's P. So I'm going to find P prime. We're using X and Y. Don't let like dy dx, that's not coming into play here. So we're just taking the derivative. The derivative of 48y is 48. The derivative of y squared is 2y. That's my derivative. That's what P prime is. Now I'm going to take that derivative and I'm going to set it equal to 0. So I'm kind of running out of space, but let's just move over here. So negative 2y equals negative 48. I subtracted the 48 over. I'm then going to divide by negative 2, divide by negative 2. What's my y going to be equal to? My y is 24. That is what my y should be. This is probably the least important thing, but let's make sure that 24 is a maximum. We got this number. Let's see if it's a maximum. So we're going to throw it on a number line. Just like we did before, it's a maximum. We're trying to see, is 24 that maximum? Technically, we could talk about endpoints. Our endpoints here would be like 0 and 48, because I want two numbers to add to get 48, and we wouldn't want to get in a negative world, but it's okay if we don't get too crazy with that on this one. A number less than 24, like 1. If I plugged 1 into my p prime equation, because that's what I'm plugging into, I'm trying to find maximums. If I plug it in right here, 48 minus 2, is that positive or negative? Positive. Number bigger than 24, like 48. If I plug 48 into this equation, it'd be negative. Is 24 a maximum? Yes, because p prime changes from positive to negative. It's changing, f is changing from increasing to decreasing. So 24 is a maximum. Cool. This is what my y value is going to be to get us a maximum. We are trying to find the two numbers. I know what y is going to be. Y is going to be 24. What's my x value going to be? 24 as well, because we're going to take it and plug it in right there. 24 plus what gets you 48? It's 24. This is the answer to the question. Questions on something we did there? Understand what we did again. We looked, which equation are we trying to maximize? What other information did they give me? Then I substituted in, so that way we only had one letter. Took the derivative, set it equal to 0 and solved, and found maximums. Questions? Let's do it again. Number 2, a little bit tougher. It says a rectangle has a base on the x-axis, and its upper two vertices are on the parabola 12 minus x squared. What is the largest area of the rectangle can have? So just a visual of that. Here's that graph, 12 minus x squared. You have a rectangle whose base is on the x-axis. All right, so imagine what this looks like. And the two vertices are on 12 minus x squared. So it's like you have a line like this on the bottom that goes up this high, and that far over. That's a rectangle whose 2 points are in the parabola. Or maybe they're talking about this parabola, or this rectangle that looks like this. Or maybe it's this guy that goes like this. Nope, not down that far. We're trying to figure out which one of those, the pink, the orange, the purple, which one is going to have the biggest area, because I'm trying to maximize area here. Kind of makes sense what we're doing? It's a little bit funky. All right. Which equation are we trying to maximize in this case? What are we trying to figure out the biggest or smallest of? Area. Okay. What is the largest area the rectangle can have? So I need to write an equation that talks about area. I'm finding the area of a rectangle. What is the formula for area of a rectangle? Length times width, or base times height, or whatever you want to call it. Length times width is what Dev told us, so that's what we'll go with. Length times width. But length times width doesn't really help us here because we're dealing with a graph, right? We've got x's and y's. So let's put this in terms of x and y. Think a little bit about this. What is your length compared to what is your width? Write an equation with x and y. Talk with your neighbor if you need to. What do we think here for area? What is our formula going to be in terms of x and y up here? What is my formula going to be in terms of x and y? Somebody say an answer. It is 2x times y. Tell your neighbor, look at that. Look at that picture up there and tell your neighbor why it's 2x times y and not just x times y. Think about this, okay? It's length times width. So this is my y value for sure because this is how far up and down I go. But this is the x value. It just goes from the center over. I've got two of those. I got one that goes to the right and one that goes to the left. That is why it's 2xy and not just xy. Everybody cool with that? Great. I've got an area equation. This is what I'm trying to maximize. Unfortunately, right now it's got two letters. It's got x and y. So they better have given me some other information. That way I could write it just in terms of x or y. Is there anything else they told me that I can substitute in here so that way I could make this just in terms of x or y? Man, I got this y equation right here. Y equals 12 minus x squared. Cool. I know what y is going to be, and so I'm going to take this right here and plug it in for y. So now my area equation is going to be 2x times what my y was, 12 minus x squared. I'm substituting in. That way I only have one letter now. I got everything in terms of x like I'd like it to be. It's in a weird factored form right now, so I'm going to go ahead and distribute that in. That way it's not funky anymore. 24x minus 2x cubed. That's what a of x is. That's a lot of setup work, but once you've gotten to this point, everything else is exactly what we did yesterday. We've got an equation. It's in one letter, and I'm trying to find the maximum of it. What are you going to do at this point to find the maximum of area? Take the derivative, set it equal to 0, and solve. Go from there, see what you can do with it. We've got area. We want to find the derivative. So, Logan, what's my derivative going to look like here?
24 minus 6x squared.
Yep, 24 minus 6x squared. Good. That's his derivative. He's going to take that derivative. He's going to find critical points, so he's going to set it equal to 0. If we're solving this thing, I'm going to subtract 24. Divide by negative 6. Divide by negative 6. So x squared is 4. What is x going to be then? It is plus or minus 2. I'm going to throw it on a number line. That's my critical point. I'm going to see if they're maximums or minimums. So I'm going to make an A prime number line. Technically, we do have endpoints. These endpoints would be a number a little bit bigger than 3 and a little bit less than 3. But imagine what that triangle would look like. Does this look like a lot of area if I made a triangle or a rectangle that looked like this? No, those are minimums. We don't really need those values. Here's my graph. I'm going to put negative 2, positive 2. The negative 2 gets a little bit weird here. Technically, it's the right answer. It works as well, but let's just see it. Okay, I'm plugging in numbers, like a number between negative 2 and 2, like 0. Remember, I'm plugging them back into the derivative. So if I plug in 0 here, it would be positive. A number bigger than 2, like 3, that would be negative. A number a little bit less than negative 2, so like negative 3, that would be negative. We are decreasing, we're increasing, we're decreasing. Where is the maximum going to happen? At 2. And so x equals 2 is part of what we were trying to get to. Is x equals 2 my answer? No. The answer is what is the largest area? And so I want to know, think about my table, given my x value of 2. Technically, we could check negative 2 as well. I want to know what the area is going to be. And so to find the area, we are plugging back into our area equation. Not the derivative, but our area. If I take 2 and I plug it in here, I get 48 minus 16. I get 32. If I plugged in negative 2, I would get negative 32. It's just because you're doing some weird stuff going back and forth. 32 is the answer we're looking for here. So my answer to this question, what is the largest area? 32.